Welcome back to my channel. What we're looking at is solving rational inequalities. One of the things that we want to do when we're solving is to make sure that everything is on one side and it's greater than or less than or equal to zero. All right, so that's going to be our marker. So what we're going to do is we're going to start by subtracting 3 from both sides, right? So if I do that, I'm going to actually have x plus 32, and this is over x plus 6 minus 3, and this is less than or equal to 0. Now, I'm going to put this over 1. And the reason why I'm doing this is we're going to make an effort to have this written as a single fraction. So I do have two fractions now. So in order to make this a single fraction, I'm just going to do a quick multiplication right here. So cross multiplication. So I'm going to multiply the 1 times x plus 32 and the negative 3 times x plus 6 over that. So let us just do that quickly. So 1 times x plus 32 will still give us x plus 32. And then a negative 3 times x. So I'm going to have the negative 3 times the x plus 6 from the bottom, right? This is all going to be over 1 times x plus 6. So this is over x plus 6. Remember, this is still equal. This is still less than or equal to 0. Now we're going to simplify this by distributing this inside, okay? So we're looking at x plus 3, then negative 3x, and then this is negative 18, and this is all over x plus 6, and this is less than or equal to 0. Again, we're going to put together our terms that are alike. So we actually have terms that are alike right there, and we have another pair that are alike here. So let's put those together. X plus x plus a negative 3x is going to give me a negative 2x, and 32 minus 18 will give me a positive 14, right? And then this will be over x plus 6, and this is less than or equal to 0. And at this stage, we're now at a regular place where we're going to check for critical values, right? So in an effort to check for our critical values, we're going to examine our denominator or numerator. So right now, I'm checking for critical values. So I'm going to put critical values right here. So I'm checking for critical values. So I'm going to focus on my denominator. So on my denominator, I have x plus 6. Now, to ensure that this is defined, this cannot equal to 0. So let us subtract 6 from both sides to find what is that number that will make this function undefined. So x cannot be negative 6, and we're going to have to keep that in our minds, okay? So x cannot be negative 6. So this is one critical value. Let's find the next critical value by taking negative 2x plus 14. We're going to set this equal to 0. We're going to solve. So we're going to subtract 14 from both sides, as you could see there. So we're left with negative 2x, which is equal to negative 14, okay? So in an effort to do this, we're going to divide both sides by negative 2. So you could see this negative 2 cancel on the left side, divide this by negative 2 on the right side. So x is equal to 7. So here it is. I do have another critical value. So what is going to happen now is that on my number line, let's take a look at what we're dealing with. We have a negative 6 first. We have a negative 6. So negative 6 would be, say, here. And we have a positive 7, which is to the right of that. We're going to have our two infinities. So we're going to definitely have negative infinity that side and positive infinity going there. So we're going to be testing in those regions. So we're going to pick up a number that is in this region, something that is less than negative 6. Then we're going to pick up a number between negative 6 and 7. Then we pick up a number that is greater than 7. And we're going to test to see what's going on. So let's identify the numbers that we're picking. So I'm going to take where x is equal to negative 7 All right. And then between the -6 and 7, I'm going to take x is equal to 0. And then a number that is greater than 7, I could just take x is equal to 8. These numbers are going to actually help us to see what's happening with this function here in those regions. So we're going to be testing. And remember now, we're focusing on this, where the idea must be less than. Right here is the idea must be less than or equal to 0. So numbers less than 0 would be negative. So we're checking for negatives here. So let us do our test. Our first test, I'm going to say, so I could just put a little line right here. So test number 1, I'm going to take -2x plus 14, and this is over x plus 6. Mark you that I'm testing where x is equal to -7 right now, okay? So I'm just going to drop a little line here. So x is equal to -7. So I'm going to be substituting -7. So, so we substitute there. So this is going to turn this into positive. So this negative 2 times -7, that's a positive 14 plus 14 all over -1. So bottom line, we're looking at 28 over -1, and this is a negative number. The bottom line is it's a negative number, right? That means this region here is good for what we're doing because we do have a negative number right there. And we're looking for numbers that are less than 0, so that's good, all right? Now, let us take a look at our second test. On our second test, remember, x is equal to 0 here. We're going to substitute right here. So it's -2x plus 14. And this is going to be over x plus 6. We're going to substitute. So -2 times 0 plus 14. And this is over 0 plus 6. Now, -2 times 0, that's 0. So we're left with 14 over 0 plus 6 is 6. And this is basically positive divided by positive. So the value is not necessary. We're saying what we do have here is a positive number is divided by a positive number. So the result is positive. And we are not looking for a positive. So the number in this region is not going to work. Okay. It's not going to help us. Now let's go for the last test. We're testing a number greater than 7. So in this case, x is going to be what? 8. So let's write back what we have. So we have -2x plus 14, and this is over x plus 6. We're going to substitute 8. So -2 times 8 plus 14, and this is going to be over 8 plus 6. So this is -16 plus 14 over 14. Now let's take a look. This is going to give us a -2. All right, that's going to give us a -2. Let me write my 2 a little better. So this is -2, and it is over 14. So basically, a negative number divided by a positive number will give us a negative number right here. So this is good as well. So now we could now relax and look to see, because we do get the negative numbers that we were looking for. So what's the idea now? The idea now is just to write our solution right here as is. So let's represent this to see what's going on. So let us say I'm representing this in interval notation. All right, so the numbers that we're looking at, and this is very important because we do remember that x cannot be -6. So even though we have a less than or equal, here we're not going to include the -6, right? So basically what we have here is negative infinity to -6, and we're going to use a curve bracket because the 6 is not in the -6 is not a part of the solution because x cannot be -6. Okay. All right. So that's that. Also, for this part, this here, this 7 is a part of the solution, right? So what it means is that we're going to be using a square bracket here because we're taking it from 7 and it's going all the way to positive infinity. And so it's going all the way to positive infinity. So we have to use a curve for that infinity. And so the response is going to be the union of these intervals that we're dealing with. And this would have been the solution. Thank you for watching my channel. We'll see you next time where I will be looking at another video. Bye-bye.